my name is Bridget Smith, and I did a research proposal on the effect of preservatives on fungal growth. Okay, so a little background on preservatives. Food preservatives were introduced in early cultures about 12,000 BC, and they used drying and salting to preserve their food. But obviously we don't use that today, so it has developed over time. And chemical preservatives came around in about 1902, and they're now today what we know as colorless and tasteless, and we don't even notice them in our food. Preservatives work by crossing fungal membranes and disrupting the membrane transport system of the mold, so it can't grow anymore and it eventually dies. Radiation is another form of preservation that has developed over the recent years, and it reduces pathogen bacteria, kills parasites, and extends the shelf life of the food. It's still being researched, but it's known that doses of 10 kGy is okay for food and it doesn't have an effect on it. But higher doses can cause unwanted chemical changes that can be bad for the food. So some foods, like meat, have a definite, it's really good for it and it's good for preservation of meat, but seafood and vegetables are still being researched. So what I'll be looking at specifically in my experiment is how effective calcium carbonate, ethanol, and sulfur are on preventing fungal growth on bread. And I picked these preservatives because they are what's most commonly used in bread today. So some previous experiments done on bread with fungi. The first one tested the effect of ethanol on fungal growth. It tested the two most common molds that grow on bread, H. burtoni and C. cytophilia. And they tested on sliced bread and synthetic media. The results showed that the H. burtoni was less effective than the C. cytophilia, and the ethanol worked on the C. cytophilia even at the lowest concentration, but it needed higher concentrations for the H. burtoni. For the second experiment I looked at, it tested the effect of sourdough and calcium carbonate on the shelf life of salt-reduced bread. They used Penicillium, Fusarium, Colmorium, and Aspergillus niger as the molds on the bread. They found that the sourdough improved the shelf life 2 to 4 days more than the calcium carbonate did at 0.03%. And this shows that sourdough, even though it's a more natural preservative, can be stronger than the calcium carbonate, and that sometimes the chemical preservatives aren't always as strong as natural ones. So in order to test my hypothesis, which I think that after 1 week of growth, the group of bread with ethanol will have the smallest amount of fungal growth, I'm going to make 4% concentrated solutions of calcium carbonate, ethanol, and sulfur, and I'm going to do this by diluting the solution in 100 milliliters, and then I'm going to take each of the solutions and bake them into bread, and the bread is going to be natural with no preservatives in it beforehand, so that's going to be a constant, and I'm going to have 3 groups, one for each concentration, and there are going to be 100 slices of bread in each group. After the concentration samples are baked into the bread, they're going to be kept in a room at 30 degrees Celsius, and after 1 week we're going to measure the colony sizes of the mold that has grown, and the bread with the smallest colony sizes, the most consistent, is the preservative that was the most